Hello everyone, my name is Van. Right now, it's the sections where we talk about Lidar. We know edge computing, edge AI, we can deliver a lot of value, but we do need to have advanced intelligence of the sensing solutions. And Lidar definitely is one of the applications when we talk about intelligent or autonomous vehicle or robotic. So this is Advantech, and everyone's honor, we have Ouster to join us. This is Ouster Simon. Say hi.
Hello, ni hao.
Ni hao. Okay, so please allow Ben to introduce you about Ouster. So Ouster founded in 2015. It's headquartered in USA, California, same as Advantech USA. And its core focus and core business is about digital LiDAR sensing solutions. That include about a lot of applications like autonomous vehicles, robotic, industrial automation, and also smart infrastructure. So that exactly means about not only about vehicle, but also all the intelligent cities, intelligent factory, all the things. That exactly about what big Advantech, what we aim for edge AI and edge computing. And all this solid state LiDAR, that is a very good solution, also implemented by the LiDAR on chip. So, and the very best news is Ouster also merged the Verida in 2023. So that means it's really a global leaders right now. And then let us please Simon to give us some overall introduction about yourself and what you see about the past 15 years of the LiDAR trend and all the things.
Thanks, Van. It's great to be here. So, firstly, I would say I'm based in Singapore. I've been working in the industrial sector for about 15 years, selling LiDAR specifically. At first, this was for logistics and factory automation applications. Since then, the technology has developed significantly from 2 dimensions to 3 dimensions. So that's a 50% increase in dimensions. And what I've seen over this time is a massive increase in the areas we work in and a massive increase in the adoption of this technology. So from 2012, back in Europe, where we made our first proposals to customers, to today, where we work with customers all across the world, with all different types of applications, which I'll talk about later. I'm an engineer, everyone in Ouster is, and we're very proud to be supplying all of these different customers across the world.
Cool. But in case any, because right now we are to all the public, I assume someone ever heard about LiDAR, but maybe not everyone understands what exactly LiDAR is and what kind of different type of LiDAR also is offered right now. So, Simon, please share with us, what is LiDAR?
So, LiDAR is a natural technology development based on what we can see with a laser pointer. If you imagine with one laser pointer, we can do one distance measurement. If we take and we rotate that, we can do many, and we can create 2 dimensions. And what you see on the screen here is you see us taking many, essentially, laser pointers and creating a 3D view. So what we're able to do is map the entire environment around the device in 3 dimensions, getting distance to every single point accurately and essentially creating a real-time 3D view of the environment, no matter the lighting condition, no matter the environmental condition. And ultimately, that's what 3D LiDAR is. And Ouster is a pioneer because we took this from being many, essentially laser pointers stacked on top of each other to being based on a single chip. So what this means is we can bring high resolution LiDAR, high resolution 3D imaging to the entire world, and we can bring that at a much better cost to performance ratio. So that's what 3D LiDAR is, and this is why it's interesting.
Okay, cool. And people also understand LiDAR a little bit more, but people must understand what is the camera. Camera right now is everywhere. And then when camera is so popular and also so cost effective, why LiDAR is still very important for all of us? Why LiDAR is needed for autonomous and intelligent, not only about the camera?
Yeah, thanks, Van. Basically, the importance here is that 3rd dimension. Cameras are great for certain applications. I mean, this stream wouldn't happen without a camera. High resolution, two-dimensional image. But actually, it doesn't know where I am in the world. It only knows where I am in the two flat dimensions that you see. So what 3D LiDAR allows us to do is not only say where in the image you are, we can say how far away each point is. What this means then is we can say how far away is a car, how fast is it moving, where is the people, where are the objects. And the other thing is, LiDAR doesn't get tripped up by environmental conditions. So on this slide, we see a few little examples. We see a dark environment where light is actually oversaturating the camera image. There's actually a person underneath one of these lights, but actually we can't see him. But in the LiDAR image, they appear crisp and they appear clear. We see a lens with water on that is blurred, and we see an overexposed image due to bright lights. In all of these cases, LiDAR will continue to be able to perceive and map the environment no matter the lighting conditions. And that's why, for a lot of perception applications, it's very, very, very important.
Okay. Right now, I also pop out the other freestyle question, because we know LiDAR have many kinds of the different form factor or core technology. For example, like a mechanical one, semi-solid state one, or fully solid state one, or what you talk about digital LiDAR. What is exactly the difference, and what's the pro and con of all this technology?
Right, yeah. So what we spoke about here, and I showed you earlier, was what we call a mechanical LiDAR. What this means is we spin the LiDAR head around 360 degrees, and we essentially create the 3D view of the world by moving the LiDAR around. Now, this has some great benefits because it allows us to create a very high resolution, rich point cloud of the environment in 360 degrees. So we say this LiDAR is not directional because you can see all around it. When we come to semi-solid state and solid state, these devices are directional. So for example, you might only have a 120-degree field of view, but the device will typically be smaller and it may have less moving parts within it. So in principle, semi-solid state and solid state devices can be made more ruggedized, and they can be made more simply. So there can be a lower cost point of solid state. Semi-solid state is where you use a mirror or some sort of moving mirror to divert the laser beams. So there's still a moving part in there, but it's very minor. Solid state is where there are no moving parts, just like the LiDAR that you would have, say, in an iPhone, for example. So these are the different technologies, and ultimately, they come to realizing different applications where the field of view, the ruggedization of the application is important.
Okay, so we understand LiDAR and what kind of different technology can form up the different LiDAR, and also it's a pro and con. And then let us cut into the other very important question and topic. So about all the applications, what's the potential it could be? What's it is used?
So we talk about a couple of different types of application here primarily. So I'm going to use this term physical AI because it's very much a buzz at the moment, and I think there's many people talking about it. These typically are where we're taking the data and we're talking about representing the physical world in the virtual world, 3D perception. So we talk about static applications like infrastructure, and we also talk about moving applications like vehicles and robotics and mining, etc., etc. So what do you use it for? So we do 3D detection and tracking. What this means is we're able to perceive and we're able to identify objects in the environment, classify them, and give information about their real location and behavior. This could be in an airport, in a railway station. It could be, on a roadside, or it could, for example, be in a shopping arcade. Any of those areas where you perceive and you track the objects of interest. This can then be used for analytics, for safety, for near-miss detection on a roadway. We can do the classification, the volumetric, the size and the speed measurement of the objects, and we can do that no matter of the lighting condition or the weather conditions. We can also then set up zones, we can set up alerts, we can create actionable information. So, to give you an idea, the LiDAR can push out up to 300 megabits a second at the moment of data. That's a lot of data. What a lot of people want is just what's actionable. And what this is it's a reduced set of the data, and so we can perceive, and this is where the compute is very, very important to use. So we talk about this physical AI and representation of the real world in the virtual world.
Okay, so right now everyone also understand if we want to create a real 3D perceptions, and a lot of data will comes from the Ouster sensors, and maybe not only one sensor, but some other many Ouster sensors. And then that also point out the other very important thing. We also need very rugged and reliable and trusted of the edge computing, edge AI, which we can team up together with a good sensor, with a quick computer in the edge, and we can deliver values. And let us also give everyone a more clear pictures about the real applications. Please, Simon.
Yeah. So these are sort of the industry verticals which we operate. So the first is automotive, where we talk about things like robo-buses, robo-taxis. We talk about mobility applications. This is the area where there's the biggest probably potential in the long term, but ultimately this is not an industry which yields the volumes today, but it's a huge area of opportunity and growth for the future. The other three verticals are what we see today. We have real deployed, value-driven use cases where people have really realized good ROI. So first, industrial. So the two applications that are pictured here is forklift trucks in logistics facilities. The LiDARs can be used not only to navigate and do collision avoidance, they're also used to perceive the environment, to guide the truck, to understand where the holes in the pallets are and the racks are, and to localize the machine and to allow it to do path planning and to be completely AI driven. We also talk about robotics. These are things like mapping, drones, last mile delivery robots. All of these areas deal in complex environments where the areas are unknown. So LiDAR is an ideal tool for doing navigation, path planning, real-time perception, and collision avoidance. So robotics and industrial really hang together, and this goes from the heaviest duty, which we'll show you soon, to the lightest duty things like indoor logistics applications. The last vertical there is smart infrastructure. Smart infrastructure is perimeter security. It's people analytics, such as, say, retail. It's analytics in airport environments, for example, person flow, queue management. And it's also stuff such as intelligent traffic systems, which we work very closely with our IPC partners, where we do things like loop replacement and traffic control and car analytics. All of these areas have application for the 3D LiDAR data that we give due to its ruggedness and reliability. So these are the areas we work in, and one thing is clear. Every single one of these uses single or multiple devices which need to be brought together, perceived, and processed. And this is why it's very important to have the right partners for the compute and the right type of stuff for that application.
Okay, then we also come out some other new questions. So we know LiDAR is still growing business, still have the growing technologies. But let us face one brutal fact. When we talk about so many real applications, Simon, why LiDAR is not so popular yet? We still see some LiDARs to really put in the proof of concept of vehicles, or some demonstration, or some university to do some study. But we don't really see LiDAR everywhere right now. What's the problem? What's the challenge?
Yeah, that's a good question, and I don't think it's brutal. I think it's reality. So Ouster came with the concept of the digital LiDAR. So this was taking LiDAR from a complex stack of individual devices in a kind of complex rotating machine to being a single chip concept. What this does is this reduces the cost of the devices and essentially makes it more available to people. So what I'm trying to say here is that ultimately Lidar has not been adopted in a lot of these applications en masse because of the fact that traditionally the cost of these devices was huge. The first Lidars people might be aware of were things like the Velodyne HDL64, which used on autonomous vehicles and had a cost of over 100,000 US dollars back in the day. We're now at the position where we talk to customers about costs 1% of that per LiDAR. So ultimately, cost is a driver. And the second element is to do with algorithmic development. This data is hugely rich. It's hugely detailed. And what this means is there's skills and development time to actually interpret that data. And these skills are still kind of being developed because this area was an area which didn't really exist in mass 10 years ago. And now every industrial player is trying to develop their autonomy stacks and their navigation stacks around this. And this is what comes to the development time. But honestly, we see a huge increase in adoption of this technology, not just in proof of concepts, but in terms of real deployed applications. The last thing I'll say is when we talk about smart infrastructure, this area has been hugely fast to adopt. If you go to, say, Singapore Changi Airport, you will see hundreds of our LiDARs in the ceilings there tracking people. You will see them at JFK. You will see them at Heathrow. You will see them in Paris Charles de Gaulle. You'll see them in airport after airport tracking people. You'll also see them on the gates tracking the planes for docking. There are actually quite a large number of deployed devices, but often these are embedded or they're far from view. But the future is bright, and I believe that this adoption will continue, and with the availability of good quality compute and good engineers, which I think there'll be some in this room, I believe that this will continue exponentially.
Okay, understand. And Ouster merged the Velodyne in 2023. That is a very important step for even not only for two companies, but for even for LiDAR sensing ecosystem. And that setup is very important. And we know when we want to develop the autonomous vehicles or intelligent robot, LiDAR is also important. And then all of these things, we need to have the consistent and the long term of the commitment of this technology. And then that also goes to the other very, very important question. Simon, what do you see about the overall Ouster business outlook?
Yeah, as everyone knows, if they're interested in the LiDAR industry, Ouster was a startup in 2015. We delivered our first product in 2018. We've been growing at a rate of 35 to 40% every year with more and more deployments. The business outlook for our technology and product is very, very bright. We believe we have the right product. Our merger with Velodyne gave us access to a wider market, but it also meant that we could consolidate our approach to being a singular technology base. So all of our focus is on making sure we have a deployable, cost-efficient product that can go to the market, and this is being recognized by real customers. And ultimately what I see is we see this continued trajectory of the company going there. If you look at the LiDAR industry in general, what you will see is you will see a lot of companies that have a lot of interesting ideas, but not a lot of real revenue. And ultimately what we represent is we represent significant revenue with real delivered customers that are really deployed. And so I think Ouster is in the best position to be able to leverage our capabilities and basically make those commitments to customers, because the reason people like Komatsu and other big industrial customers select us is because they see us as having a real roadmap that leads them to the point of being able to continue to develop and make their products better. And we see that as well the same way. There is lots and lots of capacity in our technology. And so what that means is we have the ability to keep meeting our guidance to become profitable and ultimately drive more and more LiDAR into the market. So yeah, I see the future is bright.
Okay, cool. That is also what we expect. Because have the reasonable return of investment and we can see positive cycles to move everything forward. That is what we expect about the ecosystem. And then everyone should ever know Advantech teamed up with the heavy-duty machinery maker Komatsu for more than 20 years. And Advantech enable Komatsu to have the intelligent mining, construction, and all the autonomous solutions over there in the past 20 years or more than that. And one great news we also see, which is announced by Komatsu, not by Ouster, say Komatsu also officially team up with Ouster together. So that's a super amazing of ecosystem. Komatsu, Advantech, Ouster, right now. In fact, we should sit together. We should talk about this. So share with us what you achieved the related result with Komatsu and what's the potential future you see about Ouster solutions in Komatsu or even in heavy-duty machinery industry.
Heavy-duty machinery is one of the biggest and most obvious use case areas for our technology. On this slide here, we have two use cases. These are real deployed use cases. Number one, these are coal reclaimers. We work with multiple companies where they use our LiDARs to guide and to volumetrically measure the material and to be able to also do a mix of safety and perception. Komatsu's application is quite similar. They use our product for navigation, for terrain mapping, for volumetric measurement, and for real-time path planning on the vehicles. So on those large-scale dumper trucks, they use a suite of sensors, of which LiDAR is the primary navigation. And what they're doing there is multiple things with singular devices. A lot of people think of LiDAR as collision avoidance or object perception. But actually, what is really being done is that they're taking that data, they're fusing it with other sensor technologies, and they're creating a complete holistic view of what's around the vehicle so it can do everything. It can do navigation, it can do mapping, it can do localization, it can do volumetric. If you have a gray rock on a gray background in the dark, a camera will very much struggle to understand what's there. A LiDAR can see that clearly no matter the time of the day. And this area of automatic AHS, automatic handling systems, for something like Komatsu, the return on investment is less than 6 months typically, because they have to put drivers in these vehicles. They have to pay them a lot to work in these horrible environments, and these vehicles run a known controlled path every day. So this is a perfect application for LiDAR. And I see that we also, for example, have equipment on Lidar for various applications elsewhere. I see almost every mining customer adopting this technology. And the key that was to why they choose Ouster is the ruggedization of our product. Our product has clear shock and vibe specifications in the datasheet. We test it to a very high level of robustness, and ultimately we guarantee that the product will survive in those environments for a number of years. And this is why these customers will select us rather than selecting some other technology or competitor.
Yeah, that really proves, because Komatsu is the tier 1 heavy-duty machinery makers. Advantech also the tier 1 of the heavy-duty machinery computing edge solutions provider. And also be part of the ecosystem right now. But let us ask one very basic question. Right now, for the engineering vehicles, shock, vibration, working temperature is super critical. But we want to put LiDAR over there, not only the computer. It's very critical to Ouster about LiDAR. How you overcome this kind of the difficult application scenario?
The first part is the underlying technology. Having system on chip to create the LiDAR rather than a bunch of physically calibrated beams is critical to be able to making a robust solution. Manufacturing capability and assembly of this product is also key. All of these things fit together to create a lighter weight device, lighter weight devices easier to make, more robust. So this underlying technology is our key. We have competitors that will sell products that weigh 2 kilograms to go on these vehicles. Our product weighs 500 grams. So this is a much easier product to integrate into this. Yep. What I would say is that, the other thing is temperature and shock. Temperature, we go up to 85 degrees C and down to -40. This is extremely important for these guys. And in the next generation product, we will go further. We will do more shock, more vibe, more temperature.
Okay, cool. And then Ben's last page is Advantech want to emphasize again, not only for the intelligent factory or smart city infrastructure or public safety, all the things, we all need a LiDAR and with the rocket edge. And we just use the intelligent mine site as one of the example. Right now, we have so many intelligent heavy-duty machinery to work in the mining site. We need to ensure the vehicle run in an intelligent and high productivity and safe way. That's one thing. And also, we need to take care of the environment. So we do need good and trusted edge computing and also about the right LiDAR solution over there. So appreciate for Simon joining. And before we ending our point, we have 3 kids, and we prepare some special gift for Simon. So this is the first gift from I have 3 kids. They call Momo, Daisy, and Finn, okay? And this is the first gift they give Simon because in the LiDAR's world, nothing is black. Everything is very charming. We can see that everything will be pink. Thank you. This is the first gift from my kid.
Thank you so much. That's
okay.
Fantastic.
And the other thing is we try to find, because LiDAR give the machine an eye. They can see that. And we find the rabbit have the biggest eye. So we hope that the Ouster can take up with Advantech to give every machine a beautiful and charming eye with a big eye. We can see that, and then we can identify that. And also for the lucky, for the rabbit.
Thank you. Can see in the dark too.
Okay, the last one, because I have 3 kids. This is, if you go to our booth, you will see LiDAR is exactly looks like this, but not so cute. And it have many eyes over there, and also the line. But exactly this is a Taiwan's bubble tea. Okay, but this also stands for looks like LiDAR solutions. This comes from my 3 kids. For also Simon. Thank you so much.
Thank you so much. It's been an absolute pleasure. Now I want some tea.
Yeah. Okay. Thank you. Thank you for your joining. Thank you for your listening.
Thank you so much, everybody.
Thank you.
Thank you.
Thank you.